Hello, today I want to talk about messaging systems. I'm sure you've heard that in the middleware space, applications can communicate to each other using messaging systems. Mostly you'll hear of message brokers. So in this case, you've had examples of Rabbit MQ, Active MQ, TIBCO EMS, IBM MQ. So today I want us to focus on IBM MQ. So IBM MQ is also a message broker, and it helps communication between two disparate systems. So I want us to go through the actual message flow from one application, which I'll say is application X, and the second application B. In this scenario, I have two queue managers, queue manager A and queue manager B. So application X has a direct connection to queue manager A, and application Y is also directly connected to queue manager B. So first, application A is connected to queue manager A using an IP and a port and a channel. So to establish that communication between the application and the queue manager, there has to be an IP, a port, and a channel. So in a similar way, we have application Y connected to queue manager B through an IP, a port, and a channel. So now queue manager A is also connected to queue manager B through a channel. We'll talk about the sending channel and also the receiving channel. We'll also have terms like the local queue and a remote queue. So now let's start with application X sending a request that is going all the way to application Y. So first, application X will send a request to a particular queue on queue manager A. So queue manager A checks and finds that the queue that is that application A has sent to is actually residing in queue manager B. So this queue on queue manager A is defined as a remote queue. Okay, so now queue manager A will now need to send to push that message through a channel all the way to queue manager B for the application Y to receive that message. So what happens is that after the message has been received on queue manager A, and it has established that the queue that is meant to receive that message is on queue manager B, it will take that message from the remote queue that is defined on queue manager A. It puts it on a temporary queue that is called a transmission queue, and then using the sender channel, and the sender channel has defined the queue manager B as the destination. So using the sender channel, the message is then transmitted to queue manager B. On queue manager B, the channel is defined as the receiving channel. So what is defined as sender channel on queue manager A is the receiving channel on queue manager B. So queue manager B retrieves the message that has been sent and pushes it to the local queue. So the destination queue, remember, was in queue manager B. So on queue manager B, that queue is a local queue, and therefore the message is pushed to the local queue, and application Y is now able to consume from the local queue. That is how the communication happens when using IBM MQ, and the message broker in this case here is actually the queue managers. They are responsible for the routing and also ensuring that there is the messages are pushed to the right queues. Thank you.